In this video, I'd like to study or help students get started studying Chapter 2 of Book 1 in Classical Arithmetic. In the first chapter, we saw that arithmetic can be proven to be the first of the mathematical sciences. And in this second chapter, you can see the subtitle says, On the Definition of Number and the Monad. And what the author provides us with here in Chapter 2 is a history of the efforts of philosophers to define some terms that we would assume to be pretty simple, but when you consider them more fully, we find that they're not so simple. It's not so easy to define what a number is or what one really is in a philosophical sense. So throughout history, the philosophers worked over the course of hundreds of years to establish definitions and refine those definitions. And our author provides us with a history of that development here. Obviously, in this chapter, in classical arithmetic, we're not going to explain and get into the details of all of these philosophical ideas. This would actually be a very complicated study because the people who are named here, some of them represent different schools of philosophy. Their ideas, the words that they use and so on, assume that their system of philosophy is known and understood, and that would just be a great waste of your time. There's other ways and places to pursue that knowledge. If you're interested in the history of philosophy, there's a book that was composed by a philosopher named Diogenes Laertius on the lives of the eminent philosophers. And he writes, just as we have lives of the saints in the Catholic Church, this old philosopher wrote a history of the lives of the most famous philosophers. And if you're interested in a study like that, which is very helpful, I recommend you find a copy of the work by Diogenes Laertius. You can find a copy on the library page on the Academy website, and read through that one life at a time and learn about the different philosophers and the ideas that they were known for. Okay, so in Chapter 2 here, we study a little history of the teachings of different philosophers on the topic of number and the monad. And let me just say, if you were to take a modern philosophy class, what they often are just histories of philosophical ideas. And the problem with them is that no consideration is given to whether or not the ideas were true or false. You just learn a history of philosophical ideas, most of which are false and have been proven false. Here, the author is not doing that. He's showing us how the true definition of number has developed through history by the contributions of good philosophers who worked to make the best definitions possible based on what they were able to achieve in the time that they had while they lived and studied. So let's work through this. I'm not going to explain all of the ideas, but what I want to do is just comment briefly on some of the names and vocabulary items so that you can read through this on your own and have a decent understanding of what the author's saying. What matters most is the author is simply leading us to a final definition of number. And really, if you walk away from this chapter, that's what you want to know. You don't need to be a historian in the teaching of the philosophers. You simply need to know the final answer, which is assumed to be the best and finished definition of number. So let's read through Chapter 2, which is pretty lengthy, and not waste any more time. On the definition of number and the monad. Thales defined number conformably to the doctrine of the Egyptians. So ancient mathematical teaching originated in ancient Egypt and Babylon and Sumeria. Thales defined number according to the doctrine of the Egyptians, by whom he was instructed to be a collection of monads. So the early definition of number was a collection of monads. And you don't know what monads are, but we're going to learn that, so just be patient. Thales defined number according to the doctrine of the Egyptians. The most ancient doctrine and explanation of number was that it is a collection of monads. But Pythagoras, the great Greek philosopher who came later, Pythagoras defined number, and this gets complicated, defined number as the extension and energy of the spermatic reasons contained in the monad. And as I said, without a knowledge of the entire system of Pythagorean philosophy, you're not going to understand all the details of that, and that's not the point in this chapter. Okay? Pythagoras made the definition of number more complicated because he understood much more, or not necessarily understood, but he taught that there was much more to number and arithmetic than just a collection of monads. He believed that because the Creator had in his mind the principles of arithmetic when he created the world, that arithmetic was sort of a mystery theological science that explains everything. Okay? Pythagoras defined number to be the extension and energy of the spermatic reasons contained in the monad. I'm going to stop that discussion for now, but if you'd like to get into the details of that and understand what it all means, post on the forum and I'll write a response for you. Okay? Or otherwise, Pythagoras said number was that which prior to all things subsists in the divine intellect, by which and from which all things are coordinated and remain connumerated in an indissoluble order. That's the Pythagorean doctrine of number. And you can see there what's important is to see how Pythagoras links religion and theology, the knowledge of God, with a knowledge of arithmetic. Okay, that's a good summary of Pythagorean philosophy. Others, however, of his followers defined it to be a progression from unity through the magnitude of it. But Eudoxus, the Pythagorean, says that number is definite multitude, in which definition he distinguishes the species from the genus. The followers of Hippasus, who were called acousmatiki, or hearers, said that number is the first paradigm of the fabrication of the world, which we saw in chapter 1. And again, that it is the judicial instrument of the God who is the demiurgus, or urgus, of the universe. But Philolaus said that number is the most excellent and self-begotten bond of the eternal duration of mundane natures. Now, as we look at that summary of the development of the idea of number, what you can see is the ancient philosophers saw in arithmetic profound ideas, deep mysteries, and they believed that arithmetic contained the mind of God, or the secrets of the universe. And their understanding of number was often mixed with spiritual ideas, sort of mystery and superstitions and so on. And that's the foundation of the study of classical arithmetic. The author goes on to say, the monad, and the monad is the idea of one, or a unit. The monad is in discrete quantity that which is the least, or it is the first and common part of a discrete quantity, or the principle of a discrete quantity. According to Thymaridas, indeed, it is bounding quantity. So notice again, the study of the concept of what it means for something to be one, which we take for granted because we're familiar with the idea of one. But if we were pressed to give it a definition, we would find that we're not able to give it a good definition without assuming all different kinds of pre-existing knowledge. And what the philosophers were trying to do was establish definitions from self-evident terms that didn't require all of this assumed prior knowledge, which we're not sure is true or false. Okay, so don't think that because you're familiar with something that you actually understand and can explain it. Remember that Aristotle said that we only can say that we know something when we're able to teach it or explain it. And St. Thomas says we only know something when we understand its causes, where it comes from, and so on. Okay? In certain things, however, our reading continues, in certain things, however, as in the circle and the sphere, the middle is called the bound. But those who are more modern, which are still ancient philosophers, but more modern, they define the monad as to be that according to which everything that exists is called one. All right, this is a more modern definition, and he means a good, mature, developed definition of later philosophers. All right, he doesn't mean modern in a negative sense. He says, those who are more modern define the monad to be that according to which everything that exists is called one. So if you were to see a herd of sheep out in the field, and you were to refer to them as sheep, and I was to ask you, if there are 27 sheep in the field, what do you mean by 27? And you would have to identify something that we refer to as one sheep. You would refer to that as the unit. The idea of a unit is the idea of a monad. So monad and unit are synonyms. In modern circles, we would use the term unit. In ancient philosophy, the term monad, because we're talking about Greek vocabulary, the term monad was used as a unit. To this definition, however, the words, however collected it may be, are wanting. The followers of Chrysippus assert confusedly that the monad is one multitude. And you can see the author says that's sort of a confusing definition. One multitude. That doesn't seem to make any sense. For the monad alone is opposed to multitude. But some of the Pythagoreans said that the monad is the confine of number and parts. For from it, as from a seed and an eternal root, ratios are contrarily increased and diminished, some through a division to infinity, being always diminished by a greater number, but others being increased to infinity are again augmented. I'll read that again. Certain of the Pythagoreans said that monad is the confine of number, which refers to a multitude, and parts, which refers to parts of a magnitude or a whole. Just to make a simple explanation of the idea that's being presented here. A monad is that which we consider one. It's the first of a series of numbers which are obtained by continually adding to the one. And that addition can go on for infinity. 1, 2, 3, 4, on for infinity. All right, so when we think of the idea of one or the monad, we can think of it as the beginning of number. All right? When we think of, and that has to do with multitudes. When we think of the monad or unit as a magnitude or as a single whole, number with regard to a single whole has to do with parts. And just as we can multiply a unit or monad in number, we can multiply it to infinity. In a magnitude, which is a single whole, we can divide it to infinity. So we can divide it to a half, to a quarter, to an eighth, to a 16th. The number of what we would call the denominator will increase to infinity. Okay, so there is an infinity of division in a magnitude that begins with unity, or the monad. And there is an infinity of multiplication or increase in number, which begins, again, with the monad. All right? So the terminology, the philosophical language here in the chapter can be a little overwhelming, but the idea is pretty simple. With regard to multitudes, the monad is the first of the numbers and can be multiplied to infinity. With regard to magnitudes, the monad is the first of numbers and can be divided to infinity. All right? If you ever study calculus, I'd like you to remember this discussion about the teaching of the Pythagoreans on the monad. Okay, that's all I'm going to say about it. If you ever get to study calculus, I want you to remember that I told you to look back to chapter 2 of classical arithmetic and review, when you begin calculus, what the Pythagoreans taught about unity, okay, or the monad. Just remember that. I'm not going to say anything else about it. Okay, moving on. Some have defined the monad to be the form of forms, as comprehending in capacity or power all the reasons which are present in number. But it is considered after this manner in consequence of wholly remaining in the reason of itself, as is likewise the case with such other things as subsist through the monad. The monad, therefore, and remember, I told you that we're not going to explain every concept that's mentioned in this chapter because that would be impossible. We would have to understand the different systems of philosophy. Some are Pythagoreans, some we saw are coming from ancient Egypt, some are Stoics, and so on. To understand all those details would be really impossible for a lesson like this. And it's not the author's point. The author is simply showing us that there has been a controversial development of the definition of these terms of number and of monad throughout the history of philosophy. And we're trying to find, by the end of this chapter, what the true and final definition is going to be that we're going to use in our study of classical arithmetic. Okay? The monad, therefore, is the principle and element of numbers. The beginning, we can think of the principle as the beginning, and we can think of the element as the building block from which all other numbers are produced. The monad is the principle and element of numbers, which, while multitude is diminished by subtraction, is itself deprived of every number and remains stable and firm. That is, the monad is deprived of any number. It cannot be subtracted. It cannot be reduced except by division. It is itself deprived of every number and remains stable and firm, since it is not possible for division to proceed beyond the monad. And by division there, it means subtraction, okay? Because division, all division is the subtracting of a quantity again and again from some other quantity. If we divide the one, that is the monad, if we divide it, which is in sensible things, into parts, if we divide a body, one body, which is a magnitude, if we divide it into parts, the one magnitude becomes multitude, a multitude of parts and many. And by a subtraction of each of the parts, we end with one. We end with one part. If we again divide this one part into smaller parts, the parts will become a multitude again. And by an oblation or subtraction, oblation just means subtraction, by an oblation of each of the parts, we shall at length arrive again at unity. So if we take one body, a magnitude, and divide it into parts, and then subtract the parts one by one, we'll return 2 a unity again, though it'll be a small part of the original magnitude. And then if we take that final part, which will be a unity, we can divide it again into a multitude of parts. And then by subtraction, or the word he used is ablation, we take away the parts one by one, we'll return again to another monad or unity. So that the one, so far as it is impartible, let me repeat that. So that the one, so far as one, is impartible and indivisible. And this is a very confusing sentence when students first read this chapter, because impartible and indivisible seem to have the same meaning. They both seem to mean indivisible. So what I recommend you do is, when you get to that sentence, the one is impartible and indivisible, I recommend you use the Oxford English Dictionary to look up those two terms and see what you find. The one is impartible and indivisible. What it ultimately means is that one can be divided, in the sense that it can be divided into parts, as a magnitude is divided into a multitude of parts. And yet at the same time, one cannot be divided in the sense of a multitude, because there's no number contained in one to be subtracted. Okay? And again, it's a complicated idea that you've got to wrestle with a little bit, but it's possible to say of the monad that it can be divided and also that it cannot be divided if we're speaking in two different senses. With regard to one, as far as it relates to multitude, the number one cannot be divided. But as it relates to magnitude, it can be divided into parts, and therefore the monad is both divisible and indivisible. Enough for that, okay? Another number, indeed, when divided, is diminished, and is divided into parts less than itself. Thus, for instance, the number 6, which is a multitude, it may be divided into 3 and 3, or into 4 and 2, or into 5 and 1. But the one in sensible things, that is, in bodies or magnitudes, if it is divided as body, it is diminished in size, and by section is divided into parts that are smaller than itself. But as a number of parts, it is increased. So one body, if divided, is divided into two parts. So the number is increased since there are now two parts. But the size of the parts has decreased since each of those parts will be smaller than the original body. Instead of the one, it becomes many. So that according to this, the one is impartible or divisible. For nothing in sensible things or bodies, which is divided into parts greater than itself. But that which is divided into parts greater than the whole, and into parts equal to the whole, is divided as number or multitude. Thus, if the one which is in sensible things, and again, when he says insensible things, he means in bodies, okay? He's talking about magnitudes there. According to this, the one is impartible, for nothing in sensibles which is divided into parts greater than itself, greater in size than itself. But that which is divided into parts greater than the whole, and into parts equal to the whole, is divided as number. Thus, if the one which is in sensible things or bodies is divided into 6 equal parts as number or multitude, it will be divided into parts equal to the whole, namely into 1, 1, 1, 1, 1, and 1, but also into parts greater than the whole, namely into 4 and 2. For 4 and 2 as numbers are more than 1, which was the whole, the multitude as a whole. Hence, the monad as a number is indivisible, or not divisible. But it is called the monad either from remaining immutable and not departing from its own nature, or, as often as the monad is multiplied into itself, it remains the monad, since 1 times 1 is 1. And if we multiply the monad to infinity, 1 times 1 times 1 times 1 to infinity, it still continues to be the monad. Or it is called the monad because it is separated and remains by itself, the idea of isolation or separation. It remains by itself alone apart from the remaining multitude of numbers. So he's asking, why was the number 1 called monad by the Greek? Why was that term used? And there he gives a couple of options for why that term might have been used. Because multiplied by itself to infinity, it always remains 1. It has this idea of unchanging stability and permanence, and therefore it was called 1. Or the other reason, which he states at the end there, is because it is separated and remains by itself alone, the monad, from the remaining multitude of numbers. Okay? Last paragraph. Since therefore number is the connective bond of all things, it is necessary that it should abide in its proper or peculiar essence, with a perpetually invariable sameness of subsistence, and that it should be compounded, but not of things of a different nature. For what could conjoin the essence of number, since its paradigm joined all things? But it seems to be a composite from itself. Moreover, nothing appears to be composed from similars, nor yet from things which are conjoined by no analogy, and which are essentially separated from each other. Hence, it is evident, since number is conjoined, that it is neither conjoined from similar things, nor from things which mutually adhere by no analogy. Hence, the primary natures of which number consists are the even and the odd, which by a certain divine power, though they are dissimilar and contrary to one another, yet flow from one source and unite in one composition and modulation. And that's the end of chapter 2. Now, that last paragraph was a real mouthful, and I'm sure that as I read it, you probably zoned out and couldn't follow. But here's the point, and we always have to remember that the author has a point. Okay, it may take you a long time before you'll be able to understand all the ideas that the author mentions in this chapter. And I can't possibly take the time in videos to explain every term that he uses. And I don't need to, because we're going to understand these things through our study of classical mathematics. So I'm not worried about whether you understand all the details as we get started. But what he's showing is that the definition of numbers and of monad has been a puzzle for philosophers through time. They have succeeded in establishing definitions, and that led to another confusing consideration, because as we seek to understand the order of all things, we seek to understand the true classes to which things belong. For example, how do we know that man is really an animal? How do we know that man is an animal? So if we take the class of things called animal, and we lump into it all of the animals, we put horses, cows, sheep, goats, snakes, dogs, fish, birds, and man, and put them all into a class, how do we know that they really all belong to that class? That when God looks at the world, he thinks of all of these different creatures as members of one great class or genus and calls them all animal. How do we know that? That's one of the things philosophers seek through natural philosophy, is to understand the true natures and essences of things, so that we can understand the categories or classes into which things are divided, because When we can categorize or class things, we can study the class, and anything that can be found true of the class, we know to be true of every single member of the class. And that's because there are an infinite number of things created in the world. The only way that we can develop a knowledge of them is by this understanding of classes of things and applying that knowledge to individuals. It's impossible for us to study individual things because they're infinite in number, relatively infinite. That study would be impossible, okay? And again, this is all related to what we learn in classical reasoning. So if you're studying reasoning, you'll either understand what I say, or if you haven't studied reasoning yet, you're going to see that you need to do so to understand these things. But when we look at the number, or we look at quantities, and we ask, first of all, are these a true class of things? Is quantity a true class into which things exist by God's will in creation? Aristotle proved that it is. It's the second of the 10 categories. But if we were to now look at the class and ask ourselves, into what species can this class of number be divided? What is the right division of number? It's a very complicated question, and the answer that the author explains here is that number divides into two classes or two species, even and odd, and there's no other possible division. The true division of numbers is into the categories of even and odd. All right, so he establishes the definition of number and the monad, without which we can't understand number. And then he asks, how can number be divided truly, according to its nature, according to what it truly is? And the answer is, number divides into even and odd. And as you'll see in the coming chapters, we're going to study number according to even and odd as the difference between all numbers, okay? I know that's a lot of information. The goal of the study of chapter 2 is to understand what number is, to understand what the monad is. And again, I told you, the monad is simply a synonym for the idea of unity, or a unit that we use in modern mathematics. And then to understand the true division of quantity into 4 different kinds of quantities, which are absolute multitudes, relative multitudes, magnitudes at rest, and magnitudes in motion. Those 4 divisions of quantity are the objects of the 4 mathematical sciences. And I know I'm pouring on you a lot of information here, but you can watch this video again and get all this. Quantity divides into 4 kinds of quantity. Absolute multitude, which is number, and arithmetic is the study. Relative multitude, which is music. Magnitude at rest, which is geometry, and magnitude in motion, which is astronomy. Those are the 4 divisions of quantity, and the 4 sciences that relate to those 4 divisions of quantity. If we were to go to the study of arithmetic and absolute multitude, or number, and ask, how does absolute multitude divide into species? The answer is, it divides into even and odd. And that's where we finish in chapter 2, okay? I know that's a lot of information. As I said, I usually pour it on students in videos because I know that, unlike a class lecture, you can just hit rewind or replay and watch the video again. So I'm not worried too much about giving too much information, but I want you to see what's contained here in chapter 2. It's a long chapter. It's full of complicated information, but if you work through it and pay attention to the author's purpose, you can come out of the chapter knowing what number is, what the monad is, and what the 2 natural divisions of number are. Okay, that's the goal of chapter 2. I hope that's a helpful introduction. Now it's time for you to study it on your own for mastery. If you need any help, please contact me by email or on the forums, and I'll help as much as you need. God bless your studies.